All right, so this is energy conservation on springs, and we just gave it as an assignment, but nothing is due today. But if you want to check your work, this was from 121. All right, so number one says a block slides on a frictionless surface with kinetic energy of 12.5 joules, hits a spring with a spring constant of 25 newtons per meter. How far does the spring compress before it stops? Before the mass stops. Okay, so you have kinetic energy is 12.5. You have K, which is 25 Newton per meter, and you want to know X. So from what Coach Pfaff said today, everything is equal to each other. So potential energy is going to be equal to the kinetic energy, and we can say that the potential energy of the spring is 1/2 kx squared, and that the potential energy is going to be equal to kinetic. So we can say that 12.5 is equal to 1/2 25x squared, and then solve for x. So half of 25, oops. Okay, is 12.5. Divide 12.5 by both sides. That's 1 equals x squared, and then the square root of 1 is 1. So it would be 1 meter. Number 2, a 0.005 kilogram mass is traveling with a velocity of 4 meters per second. So here we have the mass is 0.5 with the velocity of 4. We have the spring constant is 20. How far does it compress? So, all right, again, we can say that everything is equal to each other. So you can say that 1/2 mv squared is equal to 1/2 kx squared. So 1/2 0.54 squared is equal to 1/2 20x squared. So 0.5 I use for 1/2, and then 0.5 is the mass, times 4 squared. So the left side of the equation is 4. Half of 20 is 10. Divide 10 by both sides. 4 divided by 10 is 0.4. Take the square root of both sides to get 0.63. So the distance is 0.63 meters, so that would be 63 centimeters. Number 3, a 2 kilogram mass is pressed against a spring with a constant of K equals 100. Mass is pushed so it's compressed a distance of 0.25 meters. 0.25. The mass is released and the spring pushes the mass. How much kinetic energy will the mass have when it leaves the spring, and what will the velocity of the mass be at that point? Okay, so I'm going to say that 1/2 mv squared is equal to 1/2 kx squared. Actually, let me take a step back here. Since we have K and X, let me find the potential energy first. Okay, so there's different ways you can do these, clearly. You can set things equal or solve for one and plug it in somewhere else, depending on how you like to do that. So 100, and then the X is 0.25 squared. So 0.5 times 100 times 0.25 squared. The potential energy of this spring is 3.125. PE is equal to KE. So 3.125 will now be the kinetic energy, and you can equal that to 1/2 mv squared. So 3.125 equals 1/2 the mass of 2, and solve for the velocity squared. Okay, half of 2 is 1. bring all the other stuff down, divide 1 by both sides, and then take the square root of that. So you're going to take the square root of 3.125 to get a velocity of 1.77 meters per second. A block with a mass of 4 kilograms is moving with a velocity of 3. Okay, so mass equals 4 kilograms. Velocity equals 3 meters per second. How much kinetic energy? Okay, so you can see here, I can solve for this first. 1/2 mv squared, 1/2 4 3 squared, 0.5 times 4 times 3 squared is 18. So Ke would equal 18 joules. The block collides with a spring and compresses the spring a distance of that. What is the spring constant of the spring? So kinetic energy is going to also be equal to the potential energy of the spring. So I can say Pe equals 1/2 kx squared. We're going to look for K. We have the Pe from the kinetic, which is 18 joules equals 1/2 k. X is 0.3 squared. 0.5 times, oh, hold on, sorry. Oh, I'm going to do 0.3 squared first to get 0.09. K, 1/2, 18. Multiply both sides by 2 to cancel that 1/2. Oops. All right, so times 2, so 18 times 2 is 36. And then you have left K times 0.09. Divide 0.09 by both sides. 36 divided by 0.09 is 400. So that spring has a spring constant of 400 newtons per meter. Number 5, how much potential energy does a spring have if it has a constant, okay, compressed. All right, Pe equals 1/2 kx squared. Pe equals 1/2 10.5 squared. 1.25 joules. How much work is required to stretch? Work equals 1/2 kx squared. Work equals 1/2 25 2 squared. So that would be 50 joules of work. How much kinetic energy does 5 kilograms? It's traveling, okay, Ke equals 1/2 mv squared. Ke equals 1/2 5 4 squared. 40 joules of kinetic energy. And number 8, a mass with a kinetic energy of 35 joules. Okay, collides with a spring that has a spring constant. Okay, remember that we're going to say Ke is equal to the Pe. So 35 equals 1/2 25x squared. Divide 12.5. Half of 25 is 12.5, so divide that by both sides. So 35 divided by 12.5 is 2.8, and then take the square root of 2.8 to get 1.7. There we go.